today we will discuss pre-PSPM question from KMJ 2022-2023, question number 3. So the question states, carbon disulfate is a neurotoxic colorless volatile liquid with a formula CS2. Draw two Lewis structure of CS2 and determine the most plausible Lewis structure of CS2. So first of all, we calculate the valence electron of each atom, and we total up the valence electron for CS2 compound, and we get 16 valence electron. And we draw the Lewis structure, and from here, if we want to know the most possible Lewis structure, we need to calculate the formal charge. So I use this method, which is valence electron minus the E electron, that share of each atom. So here the S atom have 6 valence electron. We will minus with 5. Why 5? Because it's 1, 2, 3, 4, 5. So it will get positive 1. And for carbon, have 4 valence electron. We will minus with 4. Why 4? Because 1, 2, 3, and 4 go to 0. And also the second atom of S, we will get same, which is positive 1. This is our first Lewis structure. So for the second, our Lewis structure is all the formal charge is 0. And as we know that if all the formal charge is 0, so that will be the most possible Lewis structure. So we know that the second Lewis structure is the most possible Lewis structure because the formal charge is 0. So for the second question, xenon difluoride is the fluorinating noble gas compound. First, illustrate the hybridization of the central atom and draw the overlapping of the orbitals. First, we calculate the valence electron for the xenon and fluorine, and then total the valence electron, and we get 22 valence electron. And the second step is we need to draw the Lewis structure because we want to do the hybridization. So if we draw the Lewis structure and then we state the electron pair is 5 and the class is AB2, E2, E3. Why AB2, E3? Because it has 3 lone pairs, 1, 2, and 3. And then that's why it become AB2, E3. And the electron pair arrangement is trigonal by bipyramidal. And the molecular shape is linear. Why linear? Because it's straight. And the hybridization is sp3d. Why sp3d? Because the class is AB2A3, and we also can know in based on the electron pair sp3d. And then we do the hybridization for central atom, which is xenon. And then what we do for the ground state, we just show for the valence electron. So atom, we need to explain a little. Atom xenon has 4 pair electron and cannot form sigma bond with atom fluorine because for the XeF2, they will form 2 sigma bond with 3 lone pair. So at the ground state, it cannot form any sigma bond with atom fluorine. And then at the excited state, one electron from 5p orbital will promoted to unoccupied 5d orbital to form 2 sigma bond with F atom. And for F ground state, we just draw the stage, which is 2s and 2p. So here we can see they will form here, form a sigma bond. This is for the sigma bond, and we share with F atom the sigma bond. And then the hybridization will be sp3d, and then will be 5d empty orbital for 5d. Here it will form sigma bond with F atom. So the explanation is 5s 5p and 5d orbital will mix to form sp3d hybridization. And for the 5d empty orbital, we doesn't need to do the pi bond, because when we draw the Lewis structure, it doesn't have a double bond or triple bond. So we just like it and stay in here. 5d is an empty orbital. So we will draw the hybridization. So here we can see 1 sigma bond, 2 sigma bond, and here is lone pair. Here also lone pair and lone pair. So has 2 sigma bond and 3 lone pairs. That's all for me. Thank you. And then for the next question, deduce the polarity of the molecule. So it is non-polar molecule because F, X, E, and F is so here if we divide will be symmetrical of arrangement. So we can state it is non-polar molecule and bond dipole moment is symmetrical arrangement of bond dipoles, and the dipole moment can cancel each other, m equal to 0. So for the next question, question C, sodium, magnesium and aluminium are metal from period 3 in periodic table. Choose the element which has the highest boiling point and explain. So, aluminium atom has the highest boiling point among natrium and magnesium because aluminium has more valence electron and smaller size than magnesium and natrium. Attraction between positive ions and delocalize the electron, stronger and metallic bond. And more energy is required to break down the metallic bond of aluminium atom. So for this question, we just need to state that Aluminum is the highest bonding point. Why? Because it has more valence electron and has smaller size than magnesium and natrium. Between the positive ion and the localized electron stronger. For metallic bond, and it requires more energy to break down the metallic bond of the Al atom. So take note, when the increase of valence electron, the strength of the metallic is increased. That's all for me. Thank you.